Hi, I'm Julie Sarama from the University of Denver, where I'm a Kennedy Endowed Chair of Innovative Learning Technologies.
And I'm Doug Clements, also University of Denver, also distinguished university professor, but this time in early childhood education.
We're going to talk to you today about early math and how surprisingly important it is.
So let's get started. The first surprise is how surprisingly important early math really is. For instance, Greg Duncan and his colleagues did these numerous kind of reviews of thousands of kids, hundreds of teachers and all, and they looked at early entry to kindergarten reading, math, attentional, internalizing and externalizing problems and social skills. And they were looking at what predicts later school success the best. And shockingly, the best predictor was early mathematics. It predicted later reading as well as the early literacy scores did.
Right. And we don't say that necessarily that math caused reading to go up, but there's probably something going on there where kids who are good at math and are doing math are also increasing their cognitive skills overall.
Yeah, good point. Because math develops critical thinking, executive functions, social emotional competencies, language abilities. And out there, I hope some of you are skeptical. Is this a research or is this them just proselytizing about early math? No, really? Does it develop thinking skills? Well, a recent study shows that students who specifically lack math education do show reduced brain levels involved in reasoning and cognitive learning.
So that changes from correlational to really causational. We really have some physical evidence, some physical science that math is really important.
Excellent. And executive function, really? Yeah. Julie and I did a review and found that executive function is more highly related to math than other fields. And we did a study in which we found that if you do early math, more than an intervention that was designed to develop executive function, high quality earlier mathematics developed both mathematics and executive function. And we have lots of resources that kind of bring that home to teachers and other practitioners.
What about socio-emotional learning, though? I mean, one thing that we know is that people tend to think about it as either you're doing math, academics, which are boring and rote and whatever, or you're working on those sort of soft skills, which is said to help children in the long run. And we said executive function is obviously a soft skill. But what about other socio-emotional learning? How to be good friends and neighbors?
Right. Well, we know that when we plan high quality math, we do a lot of collaborative thinking and turn taking and games. But a really interesting study in the prestigious journal Child Development showed that the better you can count, the more strongly you do fair sharing. That kind of makes a little sense. If I know you've got 3 and I've got 5, I might be a little more amenable to sharing a little better with you.
Right. And in fact, though, it went beyond like, oh, we could share accurately. So they were just better at sharing.
Yes. Yeah. Good point. Good point.
And what about general language? Well, again, when we've done math interventions with teachers, there's always been a concern that if we focus on math, are we doing so to the detriment of math? And in fact, one time we met with a leader who said she was really tired of what she called a whack-a-mole approach. Do you remember that?
Yeah,
and she said either we're hammering on reading or literacy or we're hammering on math. And how do we make sure we're not doing that? Well, if we focus on math and when we have in these different interventions, what we found is that oral language, first of all, what we tried to do is, because teachers were nervous, is test some basic literacy abilities, achievement, in the fall of kindergarten after we worked with the teachers in the preschool year, kind of hoping, and that's all we were doing is hoping that we didn't hurt the kids, that they'd know their letters and they'd know their letter sounds.
They might have taken a little time away from what they would have done.
Right. Well, that was the teacher's fear.
Yes.
But in fact, the children did just as well. The children in the math group did just as well on letter naming and their letter sounds and 3 other measures of expressive languages. But the cool thing was they did better. The children in the math group did significantly better when they were asked for information. They gave more information. They had to tell back a story. There was a story they told about a naughty bus. The kids had to tell it back. The kids gave more information, used more complex sentence structures, did it more independently. They needed fewer prompts, and they answered the inferential questions better. So probably what we've done is by teachers engaging in kids in a high quality math curriculum where they're asking children how they know and how to figure out their reasoning, actually supported their language development to a great extent.
It's almost
as well.
meta-linguistic when you have to think about your own thinking and talk about it. Huh? Surprise number 2 is children have an amazingly broad, complex, and sophisticated mathematics that they can understand. And we'll try to emphasize that as we go on.
Sure.
And then
we also know a lot. There's been so much research done about how children think and learn about math, all children, done in a variety of settings, that it's kind of silly for us to sort of like take a whack-a-mole approach and try something new. We've got lots of solid research that points us in a solid direction.
For instance, we know that often kindergartners, when the children have gotten a really good preschool math experience, too many kindergarten curricula teach kids what they already know.
Exactly.
And so they're just repeating things that they learned in preschool. We also know, and this goes back to what you said about social and emotional skills, that doing more advanced content in math helps all children learn, and it helps their social emotional development as well. So rather than being either or, developmentally appropriate practice,
I think the
is
key is
both and.
Developmentally appropriate practice, though. What we don't like to see is kindergarten and preschool kids getting second and third grade curriculum in the name of continuity.
Yes.
What we are looking at is kind of flip that on its head. Let's look at what's been done in preschool that's been incredibly effective and say, how do we bring that up and capitalize that in kindergarten and first grade?
Right.
And what does all this research point us in what direction? Learning trajectories. Learning trajectories is sort of our way of synthesizing all the research from cognitive psychology, developmental psychology, early childhood, math education. Did I leave anything out? I guess cognitive science. Anyway, all that research goes together and informs learning trajectories, which has been cited in multiple policy documents.
I was honored to be on the National Research Council committee that created the report on mathematics in early childhood. And the cool thing was the subtitle of that, Learning Paths, means learning trajectories,
right,
achieves both excellence in teaching and learning and equitable teaching and learning.
Right.
Why equity?
Well, the fact of the matter is learning trajectories, I'm going to talk about it a bit later, are asset-based. They're automatically developmentally appropriate because you are always learning about children's development. You're starting where they are and you're building up. That's kind of turns it on its head what's typically done in math instruction and in all the other years, where you look at a standard, you say, okay, kids should be able to do this. I'm going to look up cute lessons and
keep doing that
activities
until they quote unquote get it.
Break it down into smaller and smaller parts, model it and things like that. Instead, and keep focusing on the kids who don't get it. Instead, with a learning trajectories approach, we're looking at all kids and saying, what do you know? Where are you developmentally? And I'm going to help you get better at this over time while I'm keeping that goal in the back of my mind.
Well, talk about the goal and the 3 parts of learning trajectories.
So a learning trajectory has 3 parts. There is a goal, which is, for lots of us, is just the standards, the state standards, the national standards, Common Core, whatever. It's a standard. Then we have a developmental progression. And the developmental progression is informed by research. That's what we were talking about. Mm-hmm. It's a synthesis of all the research. And it's how children develop, what comes first, what comes second, and not as much skills, but concepts.
And skills and processes and even mathematical disposition,
exactly.
Right? Engagement and an identity of myself as a mathematician.
Exactly. And then the third part is the teaching practices, all the stuff that goes into moving kids from one level to another.
So the goals
could be seen as getting through this garden path. And the development is all those stones along the way. And then the teaching practices, that third part is how do I move kids from one stone to another stone to another stone to get through that gate?
And we know a lot about the goals, right? We
Sure.
know the big ideas that are important.
These are the big ideas, and we can distill them down to these really big ideas, which is the best way to think about standards, or even if we break them down into smaller standards.
Research is clear that if teachers keep that big ideas in the back of their mind, even as they're doing, an activity that's just for today, the big ideas helps them direct the interaction with kids.
Right.
And wow, a lot of topics.
Right. Because even though there's a lot of big ideas, if we think about math, there's so much there. And it's actually so complex because of that. It isn't like literacy, and that the fact that math has so many different topic areas, and all the research goes across, is in each of those individual topic areas. But kids learn by weaving these areas as they move forward.
Yeah, and in literacy, at one point, the National Reading Association, NAEYC, wrote a combined report that basically laid out one learning trajectory for early literacy. We've got a lot in math that makes math especially challenging and interesting. This illustration, by the way, is from our Learning and Teaching with Learning Trajectories website that contains a lot of resources for all levels of education.
This really spells out much more detail what we're going to be talking, what we're just basically introducing here. And as I said before, learning trajectories are asset-based. They're always talking about what children know and what they can do, rather than thinking about kids as red flags. And no matter how much we talk about this, we'll hear people interview us and they'll say, yeah, but how do you break down fractions for little kids? Or how do you do? We don't. We really don't. What we do is we say, okay, what does the research say about children's understanding, let's say, of fractions? What do they get? Well, they typically understand half. Well, what do they think about half? Well, they think it's something broken in two. Do they think it's even? Well, there's some research over there that says even matters. How do we build on that if eventually we want an understanding of fractions? And so we're always looking at what the kids can do and what they don't know yet.
And the teaching practices then builds them up
from
what they know and can do. And these are effective. I won't spend a long time on this for sure, but we were funded by IES to do 10, we actually pulled off 12 studies testing a learning trajectories approach to another approach that had the same kind of activities, but not following the learning trajectories asset-based procedures, right?
And it felt weird for all the graduate students and research associates who were helping us conduct this research. And the reason why is once you've taken a learning trajectories approach where you really have taken what kids understand and develop and use that as the way to teach, it's hard to go backwards. But this is really the counterfactual. Is a very typical approach. And that is, look, here's my concept. I'm going to teach it. They didn't get it. I'm going to reteach it. I'm going to keep modeling it and reteaching it and reteaching it. And again, what we see kids as is not there yet, or the kids who already have it, good, let them be. I'm going to focus on my kids who are the red flags.
So the kids who already get it don't get anything particularly interesting. And the kids that don't get it just keep trying to do the same task rather than because people don't know about math development.
Right. Different ways, model things like that.
But if you follow the learning trajectories approach, we got so much better.
Right. And so for example, shape composition, it was giving kids exactly the right puzzles with the right kind of supports at the right time. And then
different kids got different levels of puzzles.
Right. Not different pictures, because if you leave it up to the kids, they just pick, I want to do the rocket, I want to do the bunny, no idea about where they are developmentally. But after we taught that way, the kids in the learning trajectories condition did better.
Yeah, absolutely. And they showed less frustration and more engagement.
Yes, which was true across all the kids, from the kids who were, didn't do so well in the pretest to the kids actually who were considered gifted. They were still really frustrated, in fact, even more so for puzzles and things that they couldn't get if they weren't at the right level.
Right. So we wanted, like NAEYC has said for a long time, challenging but achievable.
Exactly. There's that sweet spot.
Exactly. And we've got reviews of this for anybody that's interesting, of all our experiments on there. How did we do? We scaled up this approach, Julie. We went with multiple cities and thousands of kids, hundreds of teachers. How did the teachers learn this stuff?
As we saw, there's quite a few topics, and there's quite a bit within each topic. There's a lot of research that goes into understanding kids' development, and it's not easy. It's not something you can do in a one-shot workshop. So the way we did it is we met with teachers monthly, and we had the supported technology. And so we used an earlier version of Learning Trajectories website, but we continue to use Learning Trajectories website with groups of teachers around the world, really. I used to say around the country, but it's around the world. We have a Saturday morning group in the UK that we meet with occasionally. So anyway, what we have is this website, and we teach teachers about children's development, but we also give them support for what activities to do next, so that it's sort of like I work with kids, I do a small group, and I learn about their development. And then that helps me change the way I do activities. And so it's sort of not just like first I learn development and then I learn how to teach. It's all of a piece.
Yeah. And that interconnection between goals, development, and teaching is the core of the learning trajectory.
And that's what makes it real for teachers.
Exactly. Right. So remember, we talked about this, Julie, just as an example.
Right.
I asked the audience to just think.
Well, first of all, what example are we doing?
See?
We're doing subitizing. So subitizing is an example of one of the trajectories, and it's probably the easiest for people to understand. So we keep talking at this level of like learning trajectories are important. So this gives us a concrete way.
You probably didn't count to know how many trees there were here, right?
Everybody says three trees.
3 trees. And so the goal of this subitizing strand is for children to recognize and subitize, or recognize quickly, comes from the Latin word that means suddenly, the number and group without counting. So when you go to our website, for instance, and you click here, you see all these levels of subitizing. You can also click on learn about subitizing if you have to do more. And I would never subject you to showing you a video of me explaining subitizing, but I will point out the inclusive teaching approaches that we have there for children with disabilities or any kids who are struggling. The developmental progression, what's that about?
Well, in subitizing, it's let's look at big picture. Okay. So in the very beginning, very beginning, right? Kids are probably born with something called an approximate number system.
And then they learn to recognize a number. All we mean there is they've already got the cognitive equipment, if you will, but it takes them a while to learn to associate that with a word.
Well, it's what we did with the trees in that first example. That was recognizing a quantity. And very often you see little kids come up to you with one in each hand, 2-year-olds, 3-year-olds, and say, I have 2. So it's not counting, it's recognizing this is 2.
And it's more cognitively and developmentally fundamental than counting would be, right? It comes earlier. And then you move from perceptual subitizing, which is very similar to what Julie said, but just quick.
Yes.
Like if you guys knew 3 trees like right away, which I'm sure you all did, that's conceptual, or that's perceptual. But then you move to conceptual subitizing. So all this stuff is in the website, and we'll go back and talk about that a little more.
Just quick picture, as you can see, conceptual subitizing is very often part of kindergarten standards. So we do this in pre-K, move it up, but subitizing should never be stopped, and it goes all the way through grade 6.
Right, and Grace and Wheatley did a lot with subitizing in the 5 and 6, right? Yes. With different arrangements and different goals. But so pretend you're going to click on something like, I don't know, perceptual subitizing to 5. Where do you go?
You see a video. First of all, you see a description explaining what it is, and then you see a video, and you can watch the video to see a child giving an answer that shows us that level of thinking.
Now, without counting, just make a guess. How many frogs do you think I have here in my set? 5.
Okay.
Right. So she looked, saw, we're good. Now kids move to conceptual subitizing. And you want to show this video?
Sure.
I'll have to leap here.
Just for a quick moment. I'd like you to tell me how many grapes there are on this card. Maybe the grapes. Ready? Just for a quick moment. Grapes.
10.
Good girl.
I wasn't even counting because I knew it was 2 5 makes 10.
That's right. Well, you learned a lot, haven't you? Now I'm going to show you a card with some pennies on it. Try to tell me how many pennies are on this card when I show them to you, just for a quick moment. Ready?
$15.
So did she?
I'm like the smartest kid in my class.
Did she subitize to 10 or 15 or what was
Yeah,
happening
I mean,
now?
she got 10, and then she had to add using a counting strategy in order to figure out 15. But she did know 5 and 5 is 10.
And she did recognize the 5.
And she recognized the
she had
5
to
right
add
away.
to it.
Now, we probably don't think she's a conceptual subitizer to 10 because we don't know if she does all the arrangements and things like
We'd have
that.
to
And we
find
don't know if she knows 7 is 3 and 4. But for her, she knew 5 and 5 is 10 right away. And she used that to help her solve an addition problem, which is really nice. It shows, again, how those topics interweave.
So the counting and the subitizing came together in her problem solving there.
So that was a quick example of two levels of a learning trajectory. And then the teaching practices are, what do we do to help kids get better subitizer? Well, on the website, it has a lot of ideas for different activities. But basically, the reason why we choose subitizing as an example of a learning trajectory is it's pretty easy. You do subitizing. You get better at subitizing by doing subitizing, and you just do slightly higher numbers all the time. An example of the instruction, another instructional activity is number me or Tricky 2. We also have Foxy 4. But the idea behind Tricky 2 or any of those things is simply putting sets under bowls and picking them up and having the children find a quantity. Now, that's not perceptual subitizing. That's recognizing number because it's not done instantaneously.
Right.
But when you pick up the bowl and a child sees a set, you simply say, is this 2 or not? And the child gets to say yes or no. And therefore, they're getting this idea that there is something that looks like 2, but also sometimes they say no. They don't know what number it is, but they know it's not 2, which is important.
And the teacher can name that number.
Right, you're right. That's
and they're
not 2,
starting
that's
to
3.
learn, but they also learning the concept in the non-example of the concept. So it's very powerful. And teachers with kids at a slightly different level can go like this with it, boom, boom,
and go
and
faster.
then it is super difficult.
Well, and in fact, though, you kids can play in small group, and you could have different quantities under each bowl and ask different children to find the different numbers, and therefore you're automatically meeting kids differentiating at the appropriate level without the kids
in real time, embedded in
exactly. This child's struggling with 2. I'm going to just say find the 1. This child's got it. I'm going to ask them to find 3.
Exactly. And this is not just for the very young kids. Second graders benefit. A recent study that came out showed that number fact knowledge and number sense were developed better with kids, and they gave them some difficult. See those number patterns? Right. That one on the black dots, it's a little tricky because how do you count the corners?
Exactly.
You know what I mean? So it takes some reasoning. And Grace and we did research way up into 5th grade and found the benefits of this kind of subitizing. Well, when you were talking about know what the kids can do and adjust as you're talking, you're really talking the important teaching strategy of formative assessment, right?
Exactly. The reason why learning trajectories are probably so powerful is because we talked about oral language, right? As a teacher, instead of trying to just do an activity, how am I engaging kids? I check it off, I do it, and then I grade kids right or wrong. That's not the learning trajectories approach. Learning trajectories approach is always watching children in small groups and adjusting the activity to keep pushing kids forward.
Right.
And what happens when you do that? Well, you are continually doing formative assessment. If you think about it this way, in formative assessment, there are key questions, right? Where are you trying to go? Where are you now? And how can you get there?
How's that line up with
learning trajectories? Where are you trying to go is the goal. Where are you now is a developmental progression, trying to figure out exactly what my kids are understanding. And in order to do that, you're engaging with children much more. You're not just saying yes or no or right. What is this? It's a square. How do you know it's a square? And thinking about kids' reasoning. That's what matters more.
More math talk that really matters.
Exactly.
Not just the one simple rigid number talk.
Exactly.
Kind of
and then how do you get there? And that is all the teaching practices and instruction and all the cool activities that you can get from anywhere. But as we say, once you learn learning trajectories, you can never unlearn them. That even if somebody gives you a math book, standard textbook that you're going page 1, page 2, page 3, you tend not to do it. You tend to differentiate because you're understanding that middle bullet. And where are my children?
And you don't miss important levels of thinking that they need to develop.
Exactly.
Even if the assessment you use, like Teaching Strategies Gold, or the curriculum you use doesn't talk about that.
Exactly.
You know that it's important. So in brief, then, in the learning trajectories approach, once you've got the goal, you'd start at the beginning of the year trying to figure out what level the kids are at, trying some tasks, doing embedded assessment in those tasks, and then adapting that task, like you said, with Tricky 2,
right.
And maybe even saying, they are beyond that level. I'll level up.
Yes. And hopefully that happens very much. And this does map on very nicely to a multi-tiered approach to educational intervention, where in tier 1, you have the whole class, you have whole groups, small groups, everyday type things. Then in tier 2, you're doing small groups in biweekly sessions and recording what's happening and differentiating.
And in fact, 3 sessions maybe for some kids in your class that need it.
And then for the children who need a little bit more, that top tier, you can do it individually, really change the small group around a little bit or repeat it more often. So big question is, does this work? It sounds like we're just kind of talking a lot and not having a sense over where things are. And I guess the short answer to that question is yeah. So there's some evidence that learning trajectories work. So this slide is just lots and lots of studies have been published, lots of reports, as well as our own research. We can show our own pretty graphs and say how they work and don't. But the reality is, I think it's more convincing when you think of all the people beyond us who have investigated learning trajectories and researched them, not only in this country, but really around the world. Taking this approach is efficacious, period.
Absolutely. And one other thing we'd like to end with then is learning trajectories can be misunderstood. They're very popular now. That IES report you were the author on came up with 2 suggestions for early math
language and learning trajectories.
Right. And so we want to make sure that when you think about the goal, it's not a narrow behavioral objective. Julie already said it's the big ideas, it's processes, it's concepts. The developmental progression isn't small sequence of narrow skills or something.
Right. I mean, I think some of the people who think they're doing learning trajectories in the upper grades are really just talking about like I'm going to learn how to add fractions. Well, first I have to teach them how to get a common denominator. So that's skill 1. Then that's not what we're talking about here. We really are talking about developmental change and understanding.
Qualitative different patterns of reasoning.
Exactly.
Right? And then the instruction activities aren't just generic cute activities or rote skill-based kind of thing, but they're connected to each level and they develop thinking at each of those levels. So like you said a couple times, they don't break down the math.
Exactly.
They build up the math, right?
Exactly.
So we've got some new projects. We're happy to talk to you about them and have people join them if you know any schools, teachers, or the like that are interested.
Exactly. What we have done is we have this website, learningtrajectories.org. It's free. It's available to everybody. It's awesome, but it's difficult for teachers to work through. And one thing, trying to take definitely a collaborative approach. We've always tried to respond. We have a Learning Trajectories website because people ask for it. Similarly, the website is too much for teachers and they're super stressed. And early childhood was so stressed during the pandemic. And so the Bajillions app is a way that hopefully we're going to support teachers learning about kids' development and teaching them how to do math in a way that's easier for them.
And just-in-time support and the like. So this is the real science of mathematics. Like you said, it's based on serious research. It's asset-based, so it's grounded in children's thinking and learning. It can be individualized and the like to be culturally responsive, to meet the needs of all kids, including those with disabilities. And it provides professional development, guidance, and tools for people running professional learning communities or the like.
Yep.
Hi, everybody. Thanks for joining. Julie might be on in a second too. Again, I'm Doug Clements. I appreciate you joining. I thought I could respond to the chats in real time during the presentation, so I actually bored myself watching myself talk, but I always like listening to Julie because I couldn't respond to the chat. So thank you for putting questions and comments there. Just know I couldn't answer you, and I was interested in doing so. So Tamara asked, can we get links to the executive function study? Nothing would make me happier than to send you that. Most academics, never feel that they're read enough, right? So I'm Douglas.Clements at du.edu, DOUGLAS.CLEMENTS.du as in Denver University.edu. If you email me, I can't even put the references in the chat, but that way I can send you the PDF as well if you're interested. So thanks, Tamara, and anybody else who needs other information, please do the same thing. Katie said, will you be sharing slides? We usually don't actually share the slides because they don't have, following recent kind of better presentations kind of information. We usually don't have that much information on the slides, but handouts aplenty. There's some in the resources here online. You remember that's on your left margin there, but I am happy to send you others, including bibliography of the kind of research and things like that. The website is, thanks, Leanna, learningtrajectories.org. Learning Trajectories, one compound word, no space or dot or anything between it, .org, and it's free to everybody. We ask that you sign up, and the main reason is you can't see the videos and the like unless you actually sign up, and that's all got to do with IRB human subjects kind of permissions of the hundreds and hundreds of parents who gave us permission to put videos of their children on the web. They just wanted to make sure they weren't misused. Melissa says, having used the Learning Trajectories approach, I can attest that it worked. I wish you could go live, Melissa, and tell us what you did. But that's true. We've had Stacy Boots got a wonderful project related where she used LT squared. And one of the teachers actually has a video on the homepage of learningtrajectories.org because she was enthusiastic about use too. And people, it's not like you abandon everything else and use Learning Trajectories. Learning Trajectories can work on its own. We have a new project called Bajillions that we mentioned that we'd love if you emailed us and signed up to pilot, which will allow teachers, especially those with very young kids, 3 and 4 year olds who may not have a curriculum at all, to use it as a curriculum. But we also have many teachers who use either our curriculum or many others, especially in the primary grades, where Learning Trajectories helps them teach that better because you understand kids' thinking and how to modify activities to meet their thinking in 2 ways, really, that I hope we talked about enough or made clear. Micro adaptations are when you're in real time with people and you modify the activity as you teach, right? Macro adaptations are often where you reflect on what happened with the kids and plan new activities, new level of thinking for some kids maybe, but new activities, new materials. I can't use a die with 1 through 6. They're beyond that. I'm going to use a numerical die or a die that goes, 4 to 10 or something like that with random numbers. Yeah, good. Love that you're naming the science of math as it really is, Jessica, Tilly, and hi. Yeah, the science of math is really unfortunate. It's similar to the science of reading, where often it becomes a math wars between phonics and other approaches, where obviously we need both. Any approach that kind of left phonics behind had a weakness. but so do approaches that don't understand that math actually predicts later reading success as well as early literacy skills. So the foundational reasoning and thinking, along with vocabulary and everything else, and conceptual knowledge, scientific knowledge, is also predictive of later reading, especially when kids get into the, instead of the learning to read, the reading to learn kind of phases of later elementary school. So love that you're saying that. Chris says, given how important a student's math preparation is when they enter school, why isn't more attention being paid to improving the very early math environment in the home? Chris, we're trying. There's lots of people that are trying. Susan Levine and a lot of others, University of Chicago, are just one of the many people that are trying to provide family resources. Incidentally, our learningtrajectories.org website has a resources link for teachers, for inclusion, for teaching with children with disabilities. But to your question and your, not just a question, but you're saying we need this, Chris. We have resources for families too there. Jill, hi. Does subitizing involve a lot of rote memorization or repetition, and this develops number sense foundation? Yeah, Jill, we would actually never say rote, which often means meaningless. And I'm sure you didn't mean it that way, but it's real important that repetition is true. You need a lot of experiences. Kids who come with fewer experiences in the home, in the community, often don't automatically or spontaneously recognize small numbers. And so it's really important to have repetition, but rote, not really. Subitizing by its very nature is the first and most basic way kids quantify. And that quantification is real. It's conceptual. It's important. And the like. And Julie, I haven't seen you, so I don't know if we're having a technical issue, but I certainly don't want to dominate the conversation if you're there and trying to get on. Leanna says, is there a similar resource for grades 4+? Not that I know of. Check out the name Jer Confrey, Confrey, and you can find some resources with, she's famous for relational thinking and the like.
And you talked about subitizing. I did step away just a second about subitizing being rote or conceptual.
I said it's conceptual from the get-go. You really actually can't subitize. And infants, people, have a sensitivity to number. And if you look at the subitizing learning trajectory, you're going to love the little video that's at the foundational level, that very early infant level. That's where it grows from. And it's an important aspect. And they're children with disabilities, children with dyslexia often have a difficulty with those, what naturally develops in most people. So there may be a neurological thing for some kids that makes it more difficult for them. But if we address it early and consistently. So I agree with you with the repeated, we just don't agree with the word rote. So we have a thing about that.
I would definitely say that it's not the same as like rote memorization, because you're not memorizing. What you're doing is building a mental image of the quantity, naming that mental image of the quantity, and then quickly looking at something else and relating it to that mental quantity. So it really is constructing knowledge still. It's not just repeated pack. That's called, okay. It is, in the sense that, like, if we were talking about colors and you memorize your colors and it's rote, but then you can't actually memorize every color of blue. You see all these different shades of blue and you relate them to your idea of what blue is. So it's like that. Anyway, thank you for coming.